Hi scientists, in this video we're going to be looking at precipitation reactions, what they are and how they work. To kick things off, we're going to be looking at some states, and you're going to use these when you're writing your chemical reactions. You've probably seen these before, okay? Just going through the list, relatively self-explanatory. An S in brackets after a molecule, a product, a reactant. It's talking about that substance being in the solid state. If there's an L, that stands for liquid, okay? A reactant or product in the liquid state. AQ is a little bit different. Now that means it's in an aqueous solution. So that substance has been dissolved in water, okay? It doesn't always have to be water. You can have other solvents as well. But the majority of the time, because water is the most common solvent, that's what we're talking about, okay? So that substance has been dissolved. So it's not a liquid itself, it has been dissolved. G is for gas, so the reactant or product is in a gaseous state. And sometimes you'll have certain words above the line for the chemical reaction. So something like this has got heat. So that will indicate that heat is supplied to the reaction. So they're kind of the reaction conditions, and there's lots of different reaction conditions that you can get. An example for photosynthesis, you might often see the word sunlight written above there. So that's saying that that reaction is not going to happen unless you've got that light being supplied. Now you can also sometimes have a substance or an element written above the line as well, and that indicates a catalyst, okay? So in this case you've got PT, so that in this chemical reaction we've got a platinum catalyst, and we'll cover catalysts in another lesson. So we're going to get into precipitation reactions now. So what are they? Let's just move this, there we go. So precipitation, what does that actually mean? Precipitation occurs when ions in a solution combine to form a new compound, and that compound is of low solubility in water. The low solubility compound forms as solid particles that will eventually settle, and that's called a precipitate. So basically you've got something new that's being made in a chemical reaction, and that does not like to dissolve. So that's going to combine, it's going to come out of solution, and you're going to get a solid. So what we want to do is to be able to predict in a chemical reaction what that precipitate is going to be, okay? And that prediction is really useful in chemistry. So in order to predict whether a precipitate will form, we need to know which substances are soluble in water and which substances are insoluble. So I can hear you right now, you're screaming at the computer saying, Mr. Peluso, how on earth am I supposed to know which substances are soluble and which substances are insoluble? That's a fantastic question. I'm glad that you asked. Now before we get into it, I'll just show you a bit of an example of the use of a precipitation reaction. This one is in the medical industry. Now the actual precipitate is this one here, barium sulfate, okay? So these two compounds here, barium chloride and sodium sulfate, they're water soluble, okay? So they can be ingested or injected. But then when they combine, they make this precipitate called barium sulfate. Now this one kind of shows up, and it's used in the medical industry because if you've got this in your system and there's an X-ray, the X-rays don't go through the precipitate, so you can see what you're trying to look at a bit more clearly. So an example of a precipitation reaction, when a solution of sodium chloride is mixed with a solution of silver nitrate, a precipitate of silver chloride will form. So here's our scary looking equation here. So we've got our reactants on the left hand side, we've got sodium chloride, so table salt, silver nitrate, and we've got AQ and AQ. So they're both dissolved in solution, we can say water. And we've got our products. Now those products are sodium nitrate, oops, I stumbled there, and silver chloride. Now silver chloride is solid, so that's going to be the precipitate, okay? So what's actually going on within that reaction there, okay? So these are ionic compounds, all right? So they're dissociated, so those ions are floating around in solution, okay? Now the silver ions will combine with the chloride ions to form that solid, but these ones here, the sodium ions and the nitrate ions, they're both going to remain in solution. So visually, this is what we've got here, okay? So these are our two beakers that we're pouring in the first place. Here's our NaCl, so we've got Na ions and Cl ions. We've got our AgNO3, so Ag is here, and NO3 is here. And you combine them, so all of those ions are kind of in your resulting solution here. Now, because this product is aqueous, it actually means that those ions haven't combined. They're just floating around, okay? They're called dissociated. But this one here, they'll combine, and when they do combine, they'll come out of solution. So you get that solid product there. You can't see that very well, but it's supposed to be white. Okay, now this is something that we're going to use in this video, and I'm going to hand you out one in class, and it's going to be something not the same, but kind of similar. Now this is called a solubility table. So this is how you know what is soluble and what is not soluble, okay? It's a scary looking table, but I'll show you how to read it, okay? So we won't worry too much about it just yet. We'll use a practice question to go through that solubility table, okay? Once you know how to use this, then you'll be fine with precipitation reactions, okay? This is your holy grail in that regard. So let's do a practice problem. So the question that we've got, sorry about that. Predict the products and write a balanced equation for the reaction occurring between sodium carbonate and copper sulfate. So that's what we've got there, okay? We've got no compounds. We have to do a lot of work here. There's 4 steps, a 4-step process that I want you guys to do in order to be successful here. Step 1, I want you to write the products. So what you're doing there is, I'll probably reveal that a bit too early, I might just get rid of it. What we're doing there is it's a double displacement reaction, or a double replacement reaction, okay? So we've got sodium ions, and they're going to combine up with the sulfate ions, okay? And then the copper is going to combine with a carbonate, okay? So you're just swapping the two around, okay? So those products are going to be sodium sulfate and copper carbonate, okay? Write them down just so you don't get confused, because there's just so many words that it's easy to get jumbled up. Now I want you to write the formula of the reactants and products. So this is balancing your compounds. Now the reactants, sodium carbonate, Na2CO3. Now you're going to need to balance ions here. Sodium is a +1 ion and carbonate is a 2-, so you're going to need 2 copies of the sodium ion to balance 1 copy of the carbonate ion, okay? Balancing ionic compounds is not going to be covered in this video. And our other reactant is copper sulfate. The products here, sodium sulfate is there and copper carbonate is there. So we've got all that stuff written down. The third step is to write the balanced equation for the reaction. So here's our balanced equation, okay? You want to make sure that it's obviously balanced, so you have to balance out the atoms from the reactant side to the product side, okay? And I think you'll agree that all of these this is a balanced equation. I hope you agree that anyway. Next, we're going to use the solubility table. So that's the new thing to determine the precipitate, okay? So let's do that. Now, the reactants were aqueous because in all precipitation reactions, you're mixing liquids to begin with. So we don't have to do any work there. We have to figure out which of these two is the precipitate, okay? So the first one we're going to look at is our Na2SO4. Okay, so what we want to do here is we want to start at the top of the table looking at the name or the symbol. I'm going to go the symbol because I find that a bit easier, okay? Now we're looking for Na2SO4. So we want to scan down this list until we find something that has either Na ions or SO4 ions, okay? So go down, and the first thing right there, how good is that, is Na+. Now, soluble compounds of ion, all. So all compounds that contain sodium ions are soluble, okay? So we're happy that Na2SO4 is aqueous. Okay. Now it doesn't take the most intelligent person in the world to figure out that this is probably going to be the precipitate. But let's, for the fun of it, let's just go through it anyway. So we've got CuCO3. So we'll go back to the solubility table. So we're going to scan down here until we see Cu or CO3. So that's my scanning noise. Forgot what we were looking at. CO3, here we go, carbonates, okay? What do we know about carbonates? The soluble compounds with carbonates are Na, K, and NH4, ammonium for those of you playing at home. Now, we wanted CuCO3, so that's not part of the soluble compounds. So it says most over here, okay? So the deduction that I have to make is that CuCO3 is a precipitate. So we're going to just put the S for solid and we're done, okay? So that's our precipitate. We can celebrate because we found the precipitate. Now, oh gee. Now I'm going to just get you guys to please try a couple of questions on your own in your books. Follow the 4-step process that I talked you through, okay? Use the video to follow it. The first one is you get the compound, so that's a bit easier. The second one's a bit harder with words, okay? Good luck, guys, and I will see you in class. Oh, didn't do my sign off.